In this video, you'll see how to implement AWS Control Tower Account Factory Customization with Cisco Secure Firewall. With this solution, enterprises can deploy Cisco Secure Firewall in an AWS Hub account and then inspect traffic flowing into spoke VPCs, referred to as ingress inspection, out of the VPCs, referred to as egress inspection, and between workloads, referred to as east-west inspection, to protect against threats and unwanted access. Let's take a quick look at the solution architecture. From the AWS Control Tower interface, the user selects Hub and Spoke products to deploy. The Hub blueprint provisions the Cisco firewall stack in the Hub account utilizing AWS best practices. The Spoke blueprint provisions the Spoke product in one or more Spoke accounts where the application workloads will reside. Once traffic is flowing, each Spoke account redirects its traffic into the Hub account for inspection. This video will focus on the ingress inspection use case. Internet traffic entering a Spoke account is redirected to the AWS Gateway Load Balancer, inspected by the Cisco firewall appliances based on a defined policy, and then sent back into the Spoke account and its destination. To get started, let's go to AWS Control Tower to see the account creation process. First, we'll create a new Hub account. This screen includes a section for Account Factory Customization. Here, the user specifies the AWS Service Catalog account where their blueprints have been published and selects the Hub product to deploy. For this example, we've already specified a Service Catalog account, a Hub blueprint product, and the parameters needed to deploy the Hub blueprint. Let's create the account. Let's look at our new Hub account. We can see that a series of CloudFormation templates deployed successfully. Next, let's see the process of creating a Spoke account. As with the Hub account, the user enters their Spoke account information here. We've already entered the parameters associated with the Spoke blueprint, so let's create the account. Here's the Spoke account we created with the Spoke blueprint. Now let's test our ingress inspection architecture. To do that, we'll return to the Hub account. We'll log into the management UI of our firewall instances to validate what we deployed in the Hub account. We'll navigate to the Cisco Defense Orchestrator to find the new cloud-delivered Firewall Management Center. We'll look at the tenant configuration. Let's navigate to Device Management. We have two instances under the IE Autoscale group, representing two devices. We also have two instances for the East-West group. The errors are due to the fact that no traffic is running on the devices. The VNIs aren't receiving packets yet because we're not generating traffic. At the moment, these are simple devices with a simple access control policy on them that allows everything. Let's navigate to event logging so we can see the ingress traffic. Let's search for the two IP addresses associated with our EC2 instances. For the purposes of this example, we've now generated some test traffic against those devices. Let's take a look at the live event data. Under User Agent, we can see that traffic was generated through our Chrome Client WebKit-based browser. Here are the events of our CIS workloads. Right now, we're only seeing the Application Load Balancer IP address because we're not using the ingress route. Later on, we'll set that up so we can see the real IP address of the customer. Let's take a look at the built-in SecureX ribbon, which can be used to scan through the observables. Notice that there are some public IP addresses in the traffic. Let's select one and investigate it in Threat Response. From Threat Response, we can view Cisco's intelligence on this IP address. For instance, we can see the verdicts for this IP address. We can see additional insights through SecureX integrations. If this IP address were known to be associated with anything malicious, it would be noted on this page. We can also pivot straight into the Talos Intelligence website from here. Here we can see some details about this particular IP address. Next, let's return to Cisco Defense Orchestrator to review some additional information. The Cloud-Delivered Firewall Management Center also has a built-in Dynamic Attributes connector. Our AWS account is included here, along with an associated query. Let's filter for a custom key containing the value www. We haven't designated any workload tags, so nothing is showing up here. Let's launch an EC2 instance in the AWS region the Dynamic Attributes connector is configured for. Next, we'll select the new instance and add a tag to it. We'll specify the key as CSDAC and the value as www. Now we'll return to the Dynamic Attributes connector and check the query again. The filter has detected the instance we just launched. When you define the name of an attribute filter, it becomes the name of a dynamic object in the Firewall Management Center. Let's navigate to Object Management to see the dynamic object we created. Here's our test object. And here's the IP address associated with the instance we launched. Let's associate this object with a policy. Let's use the East-West Auto-Scale ACP policy. We'll add an access control rule to allow traffic from the test source address to some destinations. We have many options here. For instance, we can define a dynamic object as a destination, or we can define a rule against the dynamic object as a destination. Let's block any traffic to our set of dynamically changing IP addresses. As you spin up instances using the custom tag, the policy is automatically applied. Let's save our changes to the access control policy. This object is dynamically updated, so we don't need to push or deploy it on the firewall itself. You've just seen how to implement AWS Control Tower Account Factory customization with Cisco Secure Firewall for an ingress inspection use case. You can learn more about this topic in the description and links for this video. Thanks for watching. Now it's your turn to try.